negative x, y or negative y, z or negative z. Okay, so they can be grouped in one family using this bracket. Okay, for example, 100 family containing, okay, a direction like this one, meaning that the other direction is 0 or only contain one axis. One axis contain only one axis having a direction. Okay, either it is x, y or z, positive or negative. So it can be grouped into a family 100, and it's being written as this, not using this square bracket. Instead it's using this bracket. Okay, so and then the next is how to give index for the planes, okay, the crystal plane. So again, the number or the value for x, y, and z still we use HKL. So this is for x, this is for y, and this is for z. Okay. No. Okay. So if we look at this simple cubic of structure, okay. So x, y, and z at the origin, and let's say there are a place where the atomic arrangement of this structure is a simple cubic, and then if we look through this plane, okay, okay, it's y plane. Okay, for example, if we reverse a bit like this one, okay, for example, these atoms, okay, is arranged, okay, forming a plane like structure. Okay, it can be this one, it can be a plane. So if we zoom out, it actually contain a plane of atoms. Okay, a plane of atoms. Okay, for example, kenapa kita tak pernah letak? Okay, see, okay. So if we zoom in or if we zoom out, we can see that the atoms is arranged and it looks like a plane of atoms. Okay, so this is one plane, and of course if we look at the atoms arranged at this position, okay, meaning that if we look at these atoms, okay, and then the next atom somewhere here is forming a plane also, but a different direction. And again, if we look at pen color lain, right, for example, if we look at these atoms, and of course the neighboring atom and somewhere here is forming another plane, but different different direction of planes is facing to the other direction. So meaning that there are different plane can form in one single atomic structure. So that's the reason they come up with a method to index this kind of plane, because it actually reflects on how the material behave when there are some kind of external force subjected to the material. So that's the reason we need to index the plane, and then we can relate to the material behavior. Madam. Okay. Madam. Okay. Madam. Right. So, okay. So let's say this is a cubic structure and we have this plane. So now how to index this plane? So they have to index so that they know that they need to index so that they can characterize the structure. Okay. So now we forget about the application first and look at the method how to give an index to plane. All right. Okay, let's say the red area is the plane itself. This one is a plane inside the crystal structure. Okay, so let's say this one, how to index this? Let's say this one is actually half, this is half. Okay, what you have to do is identify the intercept of the planes in each of the axis. Okay, intercept. Intercept apa bahasa Melayu?
Tangan ada tu.
Hello. Intercept apa?
Pintasan?
Pintasan lagi?
Kesilangan.
Persilangan. Oh, okay. Persilangan. Okay. Barulah saya ingat kata. Alright. Pintasan, persilangan, meaning that the plane crossing the axis. Okay. The cross. Dia potong kat mana? Okay. Dia potong dekat, for example, in this plane, it's for X, it cross at half of the axis. Okay. Half of the axis, no, half of the lattice. Okay, remember this one we call it A, which is a lattice constant. Imaginary what we call it, imaginary lines that connect between the atoms, imaginary lines that connect the atoms. So this imaginary lines of this cubic, okay, is crossed at x direction, and the length is half of this lattice. Okay, and at y directions it's crossed at one lattice, and at z direction it crossed at half lattice. Okay, so now you need to identify first. Okay, this one is not negative. Okay, not negative, just a space. Okay, just a hyphen. Okay, all right. Apa lagi ni boleh buat ni? All right, intercept. Okay, all right. Taking a reciprocal of this intercept, and then give the Miller index. Okay, if you do the reciprocal of this fraction number, okay, you will obtain the Miller index. Okay, what is reciprocal? Reciprocal is apa yang Melayu? Salingan. Salingan. Okay, you turn it to the number upside down. Okay, for example, from half at the x direction, x axis, you do the reciprocal, you will get 2/1. And for 1/1, if you do reciprocal again, it will obtain 1/1, and z 2/1. So this one is actually equal to 212. So this is the index, and it's written as this bracket. Okay, so unlike direction, if you write the Miller index for the directions, you need to write as this square bracket. This indicate direction. However, this one indicate planes. All right, so this is the system for crystal structure. So we need to have the Miller index or whatever the characteristic of this crystal unit cell. They do the system so that they can format the application, relate with the interpret the behavior and something like that. So this is how the science works for the application. Otherwise, it's very difficult to identify or to the modification to discuss the behavior, something like that. So they provide this system called Miller indices. Okay, and this one is particularly in for the planes. Okay, so right. If the intercepts, okay, this is what for the clarify the previous example. For example, you have a fraction number 1/h, 1/k, 1/l, and after the reciprocal, you will get h/1, k/1, and l/1. So and over 1 is meaning that's equivalent to h, k, and l. And if you write in the index, HKL in the bracket. Okay, let's say you get, for example, this also you need to have the integer value. For example, if this one is 2 over 3, this one half, and this one is 1 over 3. Okay, so after you do the reciprocal, of course you got 3 over 2, 2 over 1, and 3 over 1. So you have to multiply by 2, multiply by 2, multiply by 2, because you want to eliminate the fraction. So it will become 6, 4, and no, sorry, 3, 4, and 6. So your index will be 3, 4, 6. Itu tak ni? Okay. So 3, 4, 6 is another plane. Okay. So actually, if you okay, never mind. So meaning that what you have to do is obtaining the integer value so that you can obtain an integer for the planes. What happens if we have a lattice plane that does not intercept? Okay, does not intercept. For example, like this. Okay, and any for this example, okay, can you give me the intercept value for HKL intercept for x, y, z? So what about x? Where is it? The value for the intersection. The cross is cross at what value of the letters?
1. 1.
1. And then what about y?
Half.
Okay, good. Z?
Don't know.
This is 0. So it's not intercept at 0.
1.
No, this is 1, but it doesn't intercept at 1. If it is intercept at 1, it will become like this. This is clearly it will intercept at 1 here, half here, and 1 here. So what do you think?
0.
Any idea?
No.
0 is here. Okay, no. All right. So what do you think? Okay, it's actually somehow okay. Of course, there must have something. It must have something. But what is it? Okay, so it is actually infinite. Why infinite? Oh, wanita pula dia. Why infinite? Because yeah, of course, there's no perfect parallel. Okay, in this world, somehow at infinite value distance, okay, it will intercept at z direction. Okay, so that's the reason we identify this as infinite. Okay, this plane seems like parallel to z direction. Okay, it's parallel to z direction. Parallel. Okay, parallel. So meaning that is actually it's not really parallel. Okay, somehow it will intersect because this cube. Okay, imagine it is one unit cell. So can you imagine one cell of our body? So what is the number of our cell? What is the number of cell in our body? It is infinite. So the number of this distance is infinite. Somehow this plane will cross the axis at z direction. Will cross at the distance of infinite. Okay, infinite to the respect of this unit cell lah. Unit cell kecil kan. So jarak dia tu, numbers of unit cell tu, it can be very infinite lah. So one is the smallest. So infinite is maybe, I don't know, infinite lah kan. Right. Okay. So that's the reason we put infinite. Right. So so for this one, if we do the reciprocal, so we got 1, 2, and 1 over infinite is equal to
0.
0. Yes, 0. So our Miller index for this plane is actually 1 to 0. Itulah dia. Okay. Right? So, faham tak? So the plane can be said to intercept at the z-axis at infinity. Okay, so infinity at z, that's where after we do the reciprocal. Okay, so z is infinite. So after we do the reciprocal, we will get 1 over infinite and 0. So in that case, we use 0 lah. Alright. Okay. So the index is 1 to 0. How about negative index? Okay. For this case, to index this plane, it is useful to use a different corner of the unit cell as the point of reference. Okay. Why? Okay. Another requirement is the planes to index, we have to make sure the planes is not intercept at the origin. This is a requirement. It must not intercept at origin. Okay. So now if you look at this origin, you can see that the plane is crossing at this origin. What you have to do, the index plane, it useful to use a different, to index this plane, it is useful to use a different corner of the unit cell as the point of reference or the origin. So where we can use, where we can move this origin. Okay, the answer is, okay, maybe difficult for you to point where is it. So the answer is here. Okay, why not here? This is origin A, this is B. Okay, why B not A? Agak-agak kenapa? Why we choose B instead of A as a origin, new origin? Or they can be all these points C, D, E, F. They all can be the origin, but we need to select only one origin that can index the plane. So YB is the selected origin, not A, not G, not E. Okay, what do you think? What is the reason?
I think so that there will be intersection on X, Y, and Z axis.
Yes, that's correct. If we select B, you can see this is a new axis for the Z direction. This is X, this is Y. So if we move to B direction, you can see they are all intercept at all axes. Okay, that's good. So if you select G, it crossing the origin. No, you cannot use G. If you use A, you can see that it's only crossing at a Y direction and X, but not Z, because Z is not crossing this Z axis. Okay, paham tak? Faham Understand or not?
Tak faham ke?
Tak faham? Tak faham Okay, let me explain once again. If you select A point as new origin, what you can see, this is the Y axis, this is X axis, and this is Z axis. Okay, Pak C, X, Y, and Z. All right. One, it must intercept. Okay, intercept. Right. So this is X and this is negative X. So if you choose A as a new origin, you can see it's crossing at negative X. Okay, fine. It's crossing at 1 in Y direction. So X equal to negative 1, Y equal to 1. But what about Z? This is your Z axis. So it's not this plane is crossing here. So meaning that you cannot use this as origin. You need to use this origin. Why? Because if you redraw the x-axis, y-axis, cuba kita pilih color lain sikit. Okay, if you choose B, this will be the new x-axis, new y-axis, and new z-axis. So it's the plane will cross here at z equal to half, and then cross here, okay, x equal to 1, and then cross here, y equal to -1. Okay, so you need to move the origin. Any point can be origin because they are all identical. Okay, identical with the neighboring unit cell. Okay, there are another unit cell here. Okay, there are another unit cell here. So the origin can be anywhere at any corner. Okay, but you need to choose the correct one so that you can get this intercept. Okay, one, you must obtain the intercept at all axes. Two, the plane is not crossing the origin. Okay, these two requirement. Okay, so the way to choose the correct origin must fulfill this requirement. One is intercept, two, not crossing the origin. Then only you can give the index to your plane. Okay. All right. Okay. So again, now this is the origin. Okay. X, Y, and Z. So X equal to is crossing at here, so x equal to 1, y equal to -1, and z, let's say this is half, so z is positive half. Okay, so if we do the reciprocal and indexing, we will obtain, what is the index value for this one? Anyone?
1, -1, 2.
Okay, 1, 1 bar 2. Okay, remember for the negative, we write as a on top of the number of this lattice constant at any respective axis. Okay, so like this. Now, can you understand or you still don't understand? Is that okay? Clear with you?
Okay. Clear,
Okay.
doctor.
All right. Good. Okay. Satu, dua, satu, dua. Salah jawapan ni. Alright, sorry this is not correct. X is positive, Y is negative, and Z is half positive. Okay, this one is wrong. Okay, this is correct. So if you don't attend this class, maybe you will follow the wrong answer. Okay, over bar at negative Y. Okay. All right. Now it is opposite. You have the index value of the Miller index and you need to draw the planes. So how to do this? Okay, let's say we have 3, 2, 3, 1, 2. It is a, I think it's very simple. As long as you have, all right. So the first one, remember, let's say we have 3, 1, 2, and then this is after reciprocal. Before the reciprocal, this is after we have done the reciprocal process. So what is the intercept? Okay, so you need to do again the reciprocal for this value. So to obtain 3, it must be 1 over 3, and this is 1, this is 1 over 2. So this is the intercept. So this is x, y, and z. So this is the value for the intercept. All right, so you draw the cube. Okay, since there's no negative, we can just determine the origin as this normal position, x, y, and z. So now we just identify the intercept for x is 1 over 3, and y is 1, and z is half. Okay, half. So you just connect all these points and then shade the plane. All right. The thing is, when you give a dimension, you have learned about drawing, right? Engineering drawing, how to write the dimension. So let's say you have x axis, y axis like this, okay? X, y. So if you scale, give a dimension 1 over 2. So if this one is, is a label as a origin. So immediately you will know that the distance from here to here is actually 1 over 2. Okay, 1 over 2. All right, the method how to write this dimension, or give the exact, you must give this value 1/3, otherwise nobody knows. Okay, so if you just give this scale and write half with the origin is correct. Without this, okay, you need, without these origins, you have to write this. Okay, so that we know that distance from here to here is actually half. Okay, it's actually half. Okay, this is very important, otherwise you will give a wrong information. So if you do it properly like this, then when people do the index, they know, okay, which plane, what is the index for the plane. So it is the proper way. You cannot just sketch because yeah I'm as the user, or who look at or assess your answer. Of course, I don't measure by ruler or something like that, or whether it is exactly half, something like that. But the drawing, the details inside the drawing, okay, tells the information itself. Okay, I don't have to measure whether the distance from here to here is half or not. Okay, a similar distance from here to here, okay, x and y has a similar, then I need to interpret it is actually half. So not like that. So you need to properly label the sketch. Okay, without the proper label, you may not able to give a correct answer. Okay, so again, we have 3, 1, and 2. This is x, this is y, this is z. Okay, once again, I will show you how to draw these planes. Okay, first we need to draw the cube. This is x, this is y, and this is z. Okay, so at the x direction, okay, if I put origin here, so I can just label as 1/3. Okay, and from origin to y is at 1, let this constant, and at z direction it is half. I'll just label like this, and I just connect all of them, all the intercept. Ta-da! Okay, any question? Boleh tak? So the method is whatever the index given, you just do the reciprocal and just directly obtain the intercept value. Okay. Any questions?
Oh.
Faham Buat kuis sedap ni. Kangkang-kangkang awak nanti. Okay. Right. Ni lah slide punya explanation. Okay. You draw this and then you got this. This is the answer. Okay. How about one, okay, 1 bar, 2 bar, and 1. Okay, this one is negative. Okay, negative. So how to do this? Okay, what is the most convenient point of the reference, meaning that the origin? Okay, so look at this. Why we select this? Because we know that the x is negative and the y is negative. So you need to choose the negative axis. Okay, negative. So since we know that y and x will be negative, so immediately you need to choose origin at here, this point. So then what you have to do, just label, okay, the intercept. Okay, of course, again, this is after reciprocal. Okay, this is the intercept. And then this is x, y, z. I advise you to write like this so that easy for you. So after you do the reciprocal, you will get -1, negative. Okay, negative half and 1. Okay, so just since you know this is the origin or the point of reference, so half must be to this direction. Okay, the reason we identify origin, because it is easy for you to later draw the plane, because sometimes students, when they draw the cube, they immediately identify the origin like this. So if they put origin here, they will tend to draw the intercept outside the box. And with that, you will give a wrong answer, because if you, maybe you give a label like this at half sometimes, but it will be, your plane will be out from the cube. So that's the reason you need to identify the origin first and draw the respective exit at the respective direction, negative, 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 or positive. Okay, so then you just locate the intercept and then connect all the intercept and just draw the plane. Okay. Okay. Okay, this one. Okay. When inside the index they have 0. Okay, what is the most convenient point of reference? Okay, so the reference, point of reference or the origin. Okay, kalau dalam coordinate kita panggil origin lah, ataupun dalam AutoCAD drawing, something like that. So we call it origin or point of reference. Okay, so of course x is negative, so you need to select the negative axis at x direction. And then y is 0, so you don't have to worry whether it is negative or positive, just take positive. And then z is positive, so it's a axis point upwards. Okay, dia inilah z arah atas. Okay, so this is your origin, and then you just draw the cube inside this origin. Okay, so the intercept is 1x, negative x, and 1 at z. Okay, so this one, okay, remember when we have this reciprocal intercept x, y, and z. This one is -1, 0, and 1. So if we do this reciprocal, we will get 1 divided by 0. So what is the answer if we divide 1 by 0?
Infinity.
Yeah, infinity. So this one divided by 1, divided by 1, we got negative 1 and 1. So what is infinity? Infinity is, if we look at the plane, it is parallel to that direction. Okay, parallel to y direction. So this plane, if we draw continuously, it is almost parallel to y direction, y axis. Okay, so if we draw, because this is a repeated uh, structure. Okay, the structure is a long range arah y though, plane though, at the y direction it will be continuous. Okay, so this distance and this distance is a infinity, the value. So so the way to draw this, remember, if there is a 0 at y, so meaning that the plane is parallel to y direction. Okay, and there are intercept at z, they are intercept at negative x. So this is how we draw the plane if we have a value of 0 in the index, in the Miller index. Okay, planes related by symmetry. Okay, this is 100, 100 y. Let's say this is the origin. Okay, let's say this is the origin. This is the origin. So this plane is intercept at x, this one lattice unit. So that's the reason it is 100. Okay, we can change the orientation of the axis. Let's say um, this is x, y, and z. Okay, so it will become 0, 1, 0. Okay, this is almost symmetry. We can rotate the axis again and give us 0, 0, 1. Okay, where is the 0, 0, 1? Let's say this axis. Okay, 0, 0. Let's say this is x axis at this direction. Then the intercept at this direction is giving us 0, 0, 1. Or then it is similar to negative 1y. Negative 1 at x direction is identical, because let's say this is our origin, this is negative x. So the planes at this side is actually 1 bar 0, 0. Okay, so it is identical between this one and this one. Okay, so actually 0, 0 is 100 is equivalent to 1 bar 0, 0. Okay, it's identical. Okay, just because of your origin, it just give this value, but actually it's the same plane. Okay, plane related by symmetry, it is grouped under one family. We call it 100 family. And the way to write this is the bracket 100 for the direction. Family planes, we have 100, and this is the bracket. This is family plane. Family, okay, because they are identical in one group. Okay, Miller indexes are the convention used to label lattice plane and direction. This mathematical description allows us to define accurately plane within a crystal and quantitatively analyze many problems in material science. Okay, earlier I have shown to you, I have showed about the Curiosity, the machine that sent to the Mars, okay, to the aerospace to investigate materials, to study materials from the space. Okay, that robot is actually using X-ray to analyze the material. So the X-ray actually uh, identify the materials based on the detection of plane. This plane, if the orientation of atom inside the materials identical to the systematically available materials in the database, then it will define that material having the same DNA, same ID. So that's the reason why this Miller index is very important. It's like a method to quantitatively identify or characterize the materials. Okay, I think that's all for this topic. Any question? Do you have any question?
Oh.
If you don't have any
No,
question,
Doctor.
let's take a break. Okay, good. Let's take a break and come back at 4 o'clock. Okay, rehat sekejap.
Okay, Madam,
Okay,
boleh tak
Doctor.
share QR? Saya tak sempat nak scan tadi.
Really? Okay. Oh ya, saya lupa nak upload topik 3 Okay, saya share kat sini topik 3. Mana tadi datang tu? Okay. Alright. The note for topic 3 in the WhatsApp group because my e-learning system is not okay today. Anyway, we still have a friend who unable to join this class by Webex. So macam mana nak buat ni? Tertinggal ni. And it's being widely applied. And basically, it's a process that really explain the solidification. Okay, why? Because to do the casting, wait. Actually, do you know what is casting? Anybody? Do you know?
No, Doctor.
Yes.
Yes. What is it?
Melting the iron and then pour into a mold.
Yes, exactly. Okay. If we have a container like this, a mold, we call it mold. Okay. So we need to melt our material first. Okay, melt. So meaning it is in liquid condition, and we pour into our molds. For example, yes.
Yang fikir tu orang tak nampak slide.
Tak nampak slide. Dia slow sikit aku. Nampak dah? Tak nampak lagi.
Nampak.
Nampak.
Oh, okay. Alright. So dia macam ni. Let's say you want to what is the famous structure? Maybe some gears, some engine blocks.
Block.
Yes. This kind of example materials, component require casting process. So to do the casting process, you need to melt. So when talk about melt, it is a liquid. And then you pour, tuangkan dia dalam mold. This is mold. So the mold has a specific shape of your product, of your component. And then it will solidify. It will become solid. Okay, of course. After leaving it cool down, it will become solid. So it is casting. It is one of process to produce a product. And this process explains the solidification. Okay, that's the reason we need to learn about casting, because it really explains the behavior of solidification. Okay, so this is learning outcome, solidification principle in the metal, mechanism of the solidification, how it grows from the liquid to the solid. Okay, you need to be able to explain the influence of cooling rate on the formation of non-dendritic, or this is new terms, dendritic of the ingot structure. Ingot structure is the cast structure itself. Okay. Okay. What is solidification? Solidification is a process of transformation of the melt of a metal and alloys into a solid phase. Okay, solidification, solidify. Okay, of course dia memejah lah, pemejalan. In bahasa we call it pemejalan. So dia memejah lah to have a solid. Okay, it must be coming from the liquid. Okay, so for example, you have this is the mold actually. The mold. Okay, let's say you want to produce a long continuous structure. You prepare a surface where the surface will go into a cooling area. We call it whatever the medium of coolant, whatever the medium to cool the metal from the liquid temperature to the room temperature. Okay, so we provide this technique for produce single crystal. Okay, sometimes this is applicable for, of course this one is not a single crystal lah, because you can see the line here. This is actually grain boundary. Similar method to produce the single crystal material. So the thing is, this is the mold. Okay, this is molten materials inside. And then this is the temperature of melting temperature. Okay, after you melt these materials, and then you bring this mold down to the cooling area, and then it start to solidify. And then the more you bring outside the furnace, the more solid will form until it is 100% removed from the furnace. So you will get 100% of solid. Okay, this process occurs when the temperature of melt is lowering below its freezing point. So the solidification associated with the formation of crystal. Of course, the solid materials for metal having its specific crystal structure. So we also call phenomena as a crystallization. Okay, during solidification, the atomic arrangement change from a random or short range order to a long range order of or crystal structure. Short range order meaning that it doesn't enough minimum size to form solid. Okay, short range order macam nak explain penting tu nak explain Alright, for example, you have this atom. Okay, after it's combined, forming a crystal structure, it will form one solid structure like this. Okay, slightly larger than a sphere. This is short range order. Okay, it's not enough to form a solid. It will anytime dissolve in the liquid of the metals. Okay, after it form a long range order of crystal structure, then it will become a solid. Okay. Why solidification? Because the initial microstructure of material forms during the solidification. It is the initial microstructure. So meaning that, right, how to relate this in the application. Okay, you want a product. Okay, your product, for example, the engine block. All right. So specific design of the engine block, the first microstructure obtained to become an engine block is actually coming from this initial microstructure, which is right after the solidification. Okay, that the initial microstructure. Okay, so the microstructure can be changed later on during a specific process. Okay, you can always change the microstructure after it becomes solid. Okay, during after it become because the most high energy usage of process is during the casting process, melting. You need to melt the steel as a specific composition of the steel, and then or the cast iron or whatever the material is, and then you need to pour through the casting process into the molds, and then you will get this initial microstructure. So you need to understand what is the first microstructure that you want. Okay, you need to know by controlling the solidification process, you will get a specific microstructure. Okay, if that particular microstructure is the one that you want, you can keep remain as it is. If you don't want that microstructure, you may need to do a post treatment process. Okay, so the mechanical property of materials such as strength, ductility are strongly influenced by the microstructure. Okay, so if the first process, casting process, you don't do it right, you may not obtain the specific properties of the engine block. Maybe you need to have a specific strength. For example, the tensile strength is equal to 300 megapascal. Okay, if you don't do the casting process properly, okay, you don't control the solidification properly, you don't get these properties. Okay, so why? Because the initial microstructure that you obtain during the solidification does not form an exact properties of the engine block. Okay, so by controlling the parameter during the solidification process, we can control the microstructure formation. Why? Because this microstructure really influence the properties. Okay, you tak boleh suka-suka dia solidkan dia. No. Okay, you need to do you need to ensure, okay, do proper study on the process parameter, then only you can get whatever the desired properties. Okay, this engine block do a specific function. Okay, it needs some design requirement. Okay, where the properties is having tensile strength and thermal resistance or thermal conductivity. There's so many function of the, not so many, I mean that there are several function of this engine block. It must support load at certain load. It must yeah, the function is like that. So the requirement to do the function is the properties, the material properties. You have to ensure that the microstructure of your product or of your cast materials must having a correct structure so that it can have a desired properties. Okay, so condition of solidification: due to the high temperature, the particles in liquid metal have a relatively high kinetic energy. In the liquid metal, molten material, sometimes dipanggil molten materials. Material yang dah dicairkan tu dileburkan. Okay, leburan. Okay, bahasa Melayu dia leburan. Okay, leburan logam. Okay.